Hello and welcome to Module 3 in our C language series. Today our session is going to focus on program control statements. We're going to cover conditional and selection statements, which are the if and the switch statement, followed by the iteration statements, which are essentially loops. We have the while, for, and do while loops. Jump statements, break and continue, which go hand in hand with iteration statements. Go to and return are for future sessions. Label statements, case and default, these go hand in hand with the switch statement and more importantly cannot exist without the switch statement. Expression statements would be any valid C expression. We've seen many of them in the last session and we will see many more in this session as well. Block statements are any block of code that begins and ends with curly braces. Now let's discuss the if statement. It could be as simple as if the expression representing the condition, note that it has to be enclosed within parentheses. What follows the condition will be executed if the condition is true. If the condition is not true or if it is false, then the statement following the else will be executed. Or you could have an if statement like this. So if the condition is true, a block of statements is executed. Else, another block of statements is executed. Now, keeping this in mind, let's write some code. Write a program to guess the magic number. The program should take in a number from the user. If it is the number the computer thought of, the user wins, else the user loses. Pretty simple, right? What's the input here? It's the number from the user. What's the process? The computer generates the number and compares that number with the number the user entered, and accordingly prints a message out. Important when you're reading a brief to figure this out, right? What exactly is going to be the input, what is going to be your process, and what's going to be the output. Now, how are we going to take in a number from the user? We saw briefly in the last session the function scanf. We're going to use scanf again, but we're going to understand how it works. So scanf requires that variables must be passed by address. Now to pass that address, we use the ampersand symbol. Now if you recall, we saw the ampersand symbol briefly in the last session, but that was more to do with bitwise logical operators. The same ampersand symbol can be used to represent the address of a variable, and that's what we are doing here. So if the user puts in a character, you can see that we have scanf %C and the ampersand preceding the variable name. Similarly for a number. But for a string, we do not use the ampersand symbol. Why? Because the variable name given to the string is the starting address for that string. We will be doing strings in more detail in the next session. So let's go ahead now and write the code. For that, we need to go to code blocks. Let's start a new file. And you can click the 3 ellipses and then put in the name as well. First up, what header files do we need to include? stdio.h because we're using printf, stdlib.h because we're using scanf, math.h because we're using a function from here to generate the number. Int main, what are the variables we need? One to hold the user's number and one to hold the number generated by the computer. Now let's generate that number. Magic num equal to rand. That's the function we're using, and this exists in math.h. printf guess the magic number scanf %d, comma, ampersand, guess. Now we need to put in the if statement. So if guess equal to, and that's the relational operator that we're using there, magic num, printf, you guessed right, semicolon, else, printf, you guessed wrong, semicolon. So let's run this now. 45, you guessed wrong. And of course, you can play around with that. Moving on. An extension to the magic number program. If the user guesses the right number, print the message you win along with another message. What does this tell you? That we need to have a block of code because we have two statements to be executed if the condition is true. If the user guesses wrong, then print the message you lose. And additionally, if the guess is greater than the magic number, print the message too high, otherwise print too low. And again, we need a block of code. So let's go and make those changes. So here we'll say if guess equal to magic number, put in that curly brace there and make sure you have a closing curly brace as well. And within that, we need to say here, you win, and we need to printf the magic number is %t, comma, magic num. Else, and again we need a code block. So again, make sure you have curly braces opening and closing. Printf, you guessed wrong, and we need to check if guess greater than magic num, then we need to printf your guess is too high, else printf your guess is too low. And of course, you could have a \n after this. That's a new line character so that these messages appear in the next line. Let's run this now. Okay, there is some problem here. We've forgotten a semicolon. Let's put that in and run. 45. Your guess is wrong. Or you guessed wrong, your guess is too high. And you can try guessing low. Let's say 10. You guessed wrong, your guess is too low. And again, you can play around with that, trying to figure out which is the magic number. Write some code to accept two numbers, A and B, from the user. So here the input is two numbers. If B is non-zero, print quotient. Otherwise, print a message, division by 0 not possible. Let's go ahead and write the code. Start a new file. Just going to call it quotient. Again, hashtag include stdio.h, and because we're using scanf, hashtag include stdlib.h. We don't need any other header files. In main, what are the variables we need? Integer a comma b, printf, enter two numbers, scanf, %d, comma, %d, comma, a, comma, b. Now we've got to check if b is not a 0. So one way to do that is to say if b not equal to 0. But a better way is just to say it like that. And this will be evaluated the same way. Why? Remember the truth table, right? Any non-zero is true. So here we are saying if B is true, which in effect means if B is not equal to 0. So if B not equal to 0, printf quotient is %d, comma, A divided by B. Else printf division by 0 is not possible. That's all. Let's just run it and see what happens. And now you see my program is hanging. Why? Because I didn't include the ampersand. And that's how important it is when I'm using scanf. So let's run that now. Let's say 80, 20, quotient is 4. Let's check if it works with zeros. We should get the appropriate message. So 80, 0. And you see we get the message accordingly. Moving on. Now we come to nested if statements. And here this is the same as we saw in the program we wrote. So if I is true or if I is not equal to 0, then check if j is true or if j not equal to 0, execute statement 1. If k is true or k not equal to 0, execute statement 2. Else statement 3. Important to note that this else is associated with this if. But this else is outside the code block. So which if is associated with this or this one? And the answer is this one, right? The clue is because it's outside the code block. Modify the previous program so that the numbers the user enters are within the limit as specified. If not, print out an appropriate message. Let's go back to the code. And what you can do is, if you want to preserve this code as is, then you can just put in a comment there and of course put another comment here and say here. So now we have to limit the numbers a user can enter. So let's use short int a comma b, and then we say printf enter any two numbers between 5 and 100, and then scanf %hd because it's short integer, and again %hd comma ampersand a ampersand b. So now we've got the two numbers. We've got to check whether both are within those limits, right? So first of all, we check if b is not equal to 0. So if b is not equal to 0, then we check if b is greater than equal to 5 and b should be less than equal to 100. So again, we're using the relational operators here to make sure that we are within these limits. And then we check if a is meeting those limits. So if a greater than equal to 5 and a less than equal to 100. So if all these conditions are true, then we'll print the quotient. And it will be %hd comma a divided by b. Else, now this else of course will relate to this particular if. So we'll print the first number a is not between 5 and 100. And then the second else will pertain to this if. And so we printf the second number b is not between 5 and 100, else print division by 0 is not possible. Right, so I hope you understood this. Let's run this now. Okay, this seems to be an error. Semicolon, run. Let's enter 40 and 5. Quotient is 8, so that works. Let's try entering the number a less than 5. So let's say 4 and 60. And we get the first number a is not between 5 and 100. Let's try that with b. So we enter 60, let's say 3. The second number b is not between 5 and 100. And now let's enter a 0 and check if that works. So 80, 0 divided by 0, not possible. Right, and of course there's a spelling mistake here, so you can just correct that. So I hope you get the idea of how nested ifs work. Moving on. The if else if ladder, that goes like this: if condition execute statement, else if condition execute statement, else if condition execute statement, and so on. Let's write some code, edit the code in the previous program so as to use the if else if ladder. So going back to the code now, we can again comment this out, and you can choose to start here. Short int a comma b, and of course you can put a comment there saying, so short int a comma b, then printf enter any two numbers between 5 and 100. Scanf %hd comma ampersand a comma ampersand b. Now we use the if else if ladder. First of all, if a less than 5 or a greater than 100, then what do? Printf first number a is not between 5 and 100. Else if not b. So this will evaluate to if b is equal to 0. Right, because it's like saying if not b not equal to 0, which means if b equal to 0, then printf division by 0 is not possible, else if b less than 5 or b greater than 100. And of course, if You're not sure how to get this, it's just the shift and backslash that gives you that symbol. It's the pipe symbol. Printf, second number b is not between 5 and 100. Else, which means a is between 5 and 100, b is not equal to 0, and b is between 5 and 100, we can print the quotient. Quotient is percentage HD, comma, a divided by b. Run this now. Let's say 80 and 4. Second number b is not between 5 and 100, right? And that again. Let's say 80 and 10, quotient is 8. Let's try entering a less than, so let's say 4 and 60. First number is not, so you see how that works, right? Moving on. The ternary operator. We've seen how the if condition is constructed. We have the ternary operator that can shorten the code. How does it work? Expression 1 is the condition to be checked. Expression 2, if the condition is fulfilled, will be executed. If the condition is not fulfilled, expression 3 is executed. Edit the magic number program to use a ternary operator. So let's go back to the code. Now we've got to use a ternary operator in this program, right? So again, what you can do here is you can comment out from this point until this point. So here we have scanf percentage %d. Now we'll use a ternary operator. What's the condition to be evaluated? Guess equal to magic num. If it is true, then we need to print these two statements. So printf, you win. And because there's another statement, no semicolon, just a comma and a printf. The magic number is percentage %d, comma, magic num. Right? Otherwise, printf, you guessed wrong. Okay, and then here we can have guess greater than magic num. Printf, your guess is too high. Else, printf, your guess is too low. Right? I hope that's clear. Condition to be evaluated. If it is true, print these two statements. Otherwise, print this. Again, condition to be evaluated. If it's true, print this. Else, print this. If you run this now, you'll see you get the same result. 45. You guessed wrong. Your guess is too high. Try a low number. You guessed wrong. Your guess is too low. And of course, you can put in a new line character there. Right, moving on. Write a program to accept a number from the user. If the number is greater than 10, print the message. This is a double-digit number. Otherwise, print the message. This is a single-digit number. So let's go and write that code. Check digit is what I'm going to call it. So again, hashtag include stdio.h, and because we have input, we're going to use scanf, so hashtag include stdlib.h. int main, we just need one variable. Now because it's going to be just single or double digits, we could have a short int num, and then printf scanf %hd, comma, ampersand num. Now we can see num less than 10, evaluate, printf, you entered a single digit number, otherwise printf, you entered a double digit number. Okay, let's run this. Let's say we enter 4, you enter a single digit number. Let's say we enter 20, you enter a double digit number. Great. But what if I enter 100? Because there's nothing stopping me. You entered a double digit number, and that's not true. So how do we check that? Number less than 10, print this, otherwise num less than 100, and we evaluate again, printf, you entered a double digit number, otherwise printf, only single and double digit numbers allowed. Let's see if this works. So what we're doing here is we're evaluating this condition. Then we enter single digit, we print single digit number. Otherwise we check if it's less than 100, then we printf double digit number. Otherwise we printf only single and double digits allowed. So let's run this now. Let's check with 5, you enter a single digit. Let's check with a double digit. Let's say 30, you enter a double digit, and now let's check with 100. Only single and double digits allowed. Okay, so this is how you can use a ternary operator. Moving on, write a program to take a number from the user and print it square and cube. Now you may have noticed in the last session when we discussed arithmetic symbols that there's no exponentiation symbol, and there isn't in C. But what we use is a function called POW, P-O-W, which comes from the header file math.h. So keeping that in mind, let's write the code. So we start a new file, square and cube. Hashtag include stdio.h, because we're going to use printf, hashtag include stdlib.h, because we're using scanf, and we need math.h as well. Int main, now we'll use a short int here, and let's call that num, and then we can have a message saying enter any number between 4 and 40. You can change these if you like. and I will print its square and scan f percentage hd comma ampersand num. Now once we have the number, we need to print its square and cube, but of course we need to make sure that the user has kept to this limit. So how do we do that? So we can say if num greater than equal to 4 and num less than equal to 40, printf the square of the number is percentage hd comma pow. We pass in the number and the power. Of course, we also need to print the cube, so we need a block of code here. Right, and printf the cube of the number is percentage hd comma pow, pass in num comma 3. Let's run this and see the output. So if I just enter 4, I have a 0. The reason for that is pow, the function, expects a double. So we at least need to provide a float. So we change this now to float and make this percentage f, and this one f as well. Now if we run it and you enter 4, you see you get 16 and 64. But maybe we don't want the zeros. In that case, what we can do is we can here have another integer. Let's have that in, let's say, int num1. So that is int format or int data type. And then here we can say num1 equal to pow of num comma 2. And then we don't use a function here. We just print num1, changing this to percentage d. Similarly here percentage d, and before this we say num1 equal to pow of num comma 3, and then printf, we change this to num1. Okay, so now if we run this, okay, what's the error here? Expected semicolon. So I think first of all there's 2 brackets there, and that's the error. So now if I type in 4, 16 and 64. And of course you can add some space there, as you know, \t will give us a tab space. So type in 5 and you get 25 and the cube as well. I hope that's clear. Moving now to the switch statement. This is a multiple branch selection statement. The way we write it is like this. Here goes the variable we will be evaluating, and these are the different values the variable can have. If the variable does not have any of these values, then control goes to the default. You can see there's a jump statement put in there, break, so that if the variable is of this value, for example, then the statement sequence is executed, and break brings us out of the switch statement altogether. Now, what's important to remember, we need to limit the number of case statements for efficiency, and case cannot exist without switch as also default. This I mentioned at the beginning of the session. To write a program using the switch statement that accomplishes the following: accept input from the user. If the user selects 1, 2, or 3, set variable x to 1, otherwise set x to 2. If user selects 4, set x to 3. If user selects 5, for any other number, print error exiting, otherwise print the value of x. So let's go ahead and write the code for this program. I'm just going to call it switch. Hashtag include stdio.h. Because we have input, we need to include stdlib.h, int main. We will have one variable called choice, and another one which is x. Now, the next thing we do is ask for the choice. So printf, enter your choice, 1 to 5. So now we write our switch statement, the variable being choice. Open curly braces, case 1. It's important that we have these indented just for easy readability. So case 2 and case 3. All three of those have x equal to 1 and break. Right? Case 4, x equal to 2 and break. Case 5, x equal to 3 and break. Default, what do? Printf, error exiting. Right? Once the break statement is encountered, then control comes outside the switch statement, where we need to print the value of x, but only if the choice is between 1 and 5. So we can check here if choice greater than equal to 1 and choice less than equal to 5, printf, the value of x is percentage d, comma, x. Now I have a question. Do we really need to have this as int, or can we use short integer? And the answer is yes, we can. Why? Because this is only 1 to 5. And so we can change this to percentage HD. Let's run our code. Okay, so why did that happen? We don't have a scanf. percentage HD, comma, ampersand choice. Enter choice 3, value of x is 1. Try that again. Enter choice 4, value of x is 2. And that's correct, right? Then let's check 7, error exiting. So that works. Moving on. Hope you've understood the switch statement. We come to iteration statements. What is an iteration? It's just a set of instructions that will be performed as long as a condition is true. We start with the for loop. General form of the for is we have initialization done here of a particular variable. Then we have a condition that will be checked every time. And then we have something that will increment a variable again. And then, of course, we'll have our statement or the code block, depending on how many statements we have. What's important to remember is that the condition is always checked at the start of the loop. Write a program now to print natural numbers from 1 through 100. Note there's no input here. So we're generating these numbers starting from 1 through to 100. How do we do that? Let's go back to code blocks. Start a new file. Let's call this natural numbers. Now, hashtag include stdio.h. We don't need any other header file, int main. Now here we need something that is going to count from 1 to 100. Let's call that counter. And since it's only 100, let's put it as short integer CTR. Then we have our loop for. We'll initialize counter to 1 starting from the first natural number. Check that counter is less than or equal to 100. So as long as that condition is true, we will print out the number and then we increment that counter by 1 every time. All we need to do then is just print out the counter, percentage HD, comma, counter. So now if we run this, you will see the numbers from 1 to 100 printed out. It's a bit crowded. So you could add a tab space by using the backslash character constant, \t. Now if you run it, there you have all the natural numbers printed out. Right? Moving on. The variations of the for loop. The comma operator. So we can have two variables initialized in the initialization section of the for loop. And that's what we're going to do here. Write a program to accept a character from the user and subtract ASCII code for 1 from that character. The code should run as long as x plus y is less than 50. X being a counter incremented in the loop. So what's y? Y will be the variable name for the character. So let's now go ahead and write the code. Before that, note the ASCII code for 1. So if you look to your right, you can see ASCII code for 1. You're looking at the decimal value here, 49. Keeping that in mind, let's go to code blocks and write the code. Hashtag include stdio.h. Because we are accepting just a character, we can use the function getChar. We don't need scanf, and therefore we don't need to include that header file stdlib.h. Now we just have int main, and we have just character y and shortened x. So we have our loop now for x equal to 0. Note how we can also say y equal to 0. And then x plus y less than 50. That's the condition. Increment is x plus plus. Now within this loop, we will ask the user to enter a character. Enter any character, A, B, etc. And then y equal to get char. That's the function. Then y equal to y minus, we need the ASCII code for 1, so we can just say 1 within single quotes. And that's all. So as long as x plus y is less than 50, this will continue. Let's run this now. Let's say A. Now you see I'm getting this prompt so many times. Why is that? That's because with getChar, we always need to flush out the input buffer. And so we need this command, fflush stdin standard input. Now if I run this, let's put in A, B. Now you can see it stopped. Why? Because x plus y is now no more less than 50. How do we know? Let's print it out. So let's say here, printf x plus y is equal to %hd and then comma x plus y. Run this now. A is 48, B is 50. Okay, so that's that. Moving on. Write a C program to print the 5 times table using the for loop. Again, there's no input here, right? We just need to generate the 5 times table. And again, we can have a counter each time multiplying it by 5. We will print until that counter is 12 or 12 times 5. So let's now go to code blocks. Five times table hashtag include stdio.h int main, and like I said, we need that counter, short int ctr. We should initialize it to 1. We do that in the for loop. If we do initialize it here, then in the for loop, we don't need to put in that initialization. So we just have a semicolon there indicating that we don't need to initialize. Then our condition, counter less than or equal to 12, counter plus plus. And all we need to do is printf %hd, we leave a tab space, comma, counter multiply, that's the multiplication symbol, 5. Okay, so counter multiply by 5, and that's all. Let's run this, and you have up to 60, right? Moving on. Write a C program to print the sum of all natural numbers between 1 and 20. So here we need to print the sum of the natural numbers, right? We don't need to print the natural numbers per se, right? Just the sum. So let's try to figure that one out. What do we need to do? So here again, there's no input, hashtag include stdio.h int main. What variables do we need? We need a counter, so short int counter, and we also need sum. Now in the loop, we'll have ctr equal to 0, comma sum equal to 0. Then we have ctr less than equal to 20, and then I can also say plus plus ctr. It doesn't make a difference whether I put the increment before or after. Why? Because with the for loop, it's going to evaluate the condition and on the basis of that execute the loop, right? This will be incremented after the loop is executed. So here what do we need to do? We need to add to the sum. You can either say sum equal to sum plus counter. A better way though is to say sum plus equal to counter. Where do we print sum? We just print it out of this loop. Now do we really need this bracket? We don't, right? Because we just have one statement, and when we say out of the loop, it will be directly in line with the for statement. So if we put it here, the printf statement that's out of the loop. The sum of the numbers is %ht, comma sum. Now if we run this, you can see there the sum is 210, and you can add that up 1 to 20, the natural numbers, and see whether that matches. Now moving on. Write a program that allows a user to log into a remote system. The user has 3 tries to enter the password. The loop should end when 3 tries are used up or the user enters the correct password. Now we're using 9999 as the password. We're not using a string. When we learn more about strings, that's when we will use those as passwords. So for now, it's just a number. Let's now go and write the code. Remember, the user has 3 tries. The file, I'm going to call that login. Now hashtag include stdio.h, and because we have input, stdlib.h, int main. Variables that we need will be short int user entry, let's call it that, right, comma password, and that's a constant 9999. For we need a counter here as well, so let's include that, right, because here we're going to say counter equal to 0. Our condition is going to be counter less than 3 because the user is allowed 3 chances, and counter plus plus. Now here we say printf, enter the password. and then scanf %HD, comma, ampersand, user entry. Then what do we do? If user entry equal to password, printf, you are successfully logged in, else printf wrong password, try again. Right? Now, after the user is successfully logged in, we don't need to be in this for loop, right? So we can have a block of code here and put in a jump statement. Break. After having logged in successfully, then control is going to come here. That is outside this for loop. But remember, control is also going to come here if the user has exhausted 3 tries, in which case we got to say that you entered a wrong password 3 times exiting. And so we'll check the value of counter. So if counter is greater than or equal to 3, printf wrong password entered 3 times exiting. Now let's run this and see what happens. Let's enter a wrong password. So we have the wrong password. Try again. Second time. Third time. But we still get the message wrong password. Try again. After which we get the message wrong password. Enter 3 times. Ideally, this message should not appear. Right? So what do? We need to change something. So here we can check else, and we need a block now. If counter is equal to 2, because remember we're starting at 0. So if it is equal to 2, then we break right, else we print wrong password, try again. Okay, and here instead of saying greater than equal to 3, we make it 2. So let's now run this. 4, 5, 6. That's the first time wrong password, try again. 3, 4, 5. Wrong password, try again. 6, 7, 8. Wrong password, enter 3 times, exiting. Okay. Right, moving on. The while loop. The form is like this. We put the condition in, and then of course we have our statements. This statement could be empty. That means we're just, kind of having a delay, as you might call it. A single statement or a block of statements. Now write some programs using while. Write code to accept only a yes or a no from the user. Let's call this yes or no. Again, hashtag include stdio.h, and we are just going to take the character Y for yes and the character N for no, in which case we don't need stdlib.h. So we can straight away start with int main, and we just need a character answer. Now we have while answer not equal to y and answer not equal to n. Right, so now within this loop, we'll have the message printf type y for yes and n for no. And then, of course, answer equal to get char. Now remember, when using get char, we have to use flush stdin. Now let's run this. Let's say we type in y. That's right, the program ends. Type in n. The program ends. Type in any other character, O, and this loop will go on until you type a yes or a no. So I hope that's clear. Moving on. Write code to print the first 20 even numbers. How do we know if a number is even? Simply by checking if the remainder is 0. Remember, any number divided by 2, if the remainder is 0, it's an even number. So let's go and write that code. We need to generate the first 20 even numbers. So file, now the first 20 even numbers, if you're talking about, within 1 to 10 we have 5 even numbers, which means our counter should be equal to, for example, 40 if we want the first 20 even numbers. So hashtag include stdio.h and then int main. Now variables that we need, short int counter. We can initialize that to the first even number, while counter less than equal to 40. And then we can say if counter %2, right? So we're using modulo here, which will give us the remainder of the counter divided by 2. If that is equal to 0, so we can introduce another bracket there. Then we print the number %hd, keep a tab space, comma, counter. And of course, we need to increment counter irrespective of whether we are printing it out or not. So we have the counter ++ here. Right? Let's run this now. And there we have it, the first 20 even numbers. Now moving on. Write code to print the first 20 numbers in the Fibonacci series. So what's the Fibonacci series? Let's go to code blocks and start a new file. The Fibonacci series is something like this. So we have 1, 1, 2, and then 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8. You see, I'm just adding up the previous numbers. 8 plus 5, 13, 13 and 8, 21, 21 plus 13, 34, and so on. How do we put this into code? Include now int main. Let's start with short int counter. I'm going to initialize that to 1. Then we have short int sum, also initialized to 1. So let's say I have a short int previous, I'm going to call it that, which is equal to 1 as well, and a short int next, which I'm going to initialize to 0. And then what we do is we print %d \t, and then %d \t, and I'm going to first print previous and sum. As I said, this is one way of doing it. You may find another way. While we need to print 20, right? So while CTR less than equal to 20, and within that loop, what we can say is next equal to sum plus previous. So if you look at next now, 0, sum plus previous would make it 2. We've already printed out 1 and 1. Now we will print out 2. So printf %hd, comma, next, right? Then we do a switching around. This is what I mean. We say previous equal to sum and sum equal to next. So what's happening here? Previous gets the value of sum. Previous will become 1. Sum gets the value of next, which is 2. Then we have next equal to sum plus previous, which will be 3. We print out 3. Right? Again, we have previous equal to sum, which is 2, and sum equal to next, which is 3. We add that up, we get 5, and so on and so forth. But of course, we need to increment counter plus plus. Now we can also put a tab space here so that we have some space between the printing out of next. And you can see here we have 1, 1, 2, 3, 5, 8, 13, etc., etc. How many numbers do we have though? 22. So what we can do is let's make this equal to 18. Let's run that now. How many do we have? 20. Why did I make it 18? Because we are already printing out the first 2. Right? I hope that's clear. Moving on. The do while loop always executes at least once. Why? Because it checks the condition at the end of the loop. And so the format is like that. Do something and then check the conditions. Jump statements. We have return, go to. I said we would do that in other sessions. Break and continue. Now we've looked at break. We need to look at continue. Coming to the exit function, it breaks out of a program. It works just like the break jump statement, which breaks out of a loop. The form is exit with an integer, and this integer would normally be 0, indicating no errors or successful program execution. When is it used? To force termination of a program. So when a mandatory condition for program execution is not fulfilled, that's when we use the exit function. We're not going to be using it in code today, but we will in future sessions. The continue statement. Similar to the break statement, instead of forcing termination like exit, forces next iteration. Write a program to print the number of spaces in a string. Now, I've put this last because this is also a precursor to what we're going to discuss in the next session, which is arrays and strings. I'm going to write this code, but you don't necessarily need to write this. You just need to observe what's happening on screen. Hashtag include stdio.h and then int main. And we're just going to have a string constant here. When I define a string in C, the way to define it is, of course, character str1, but then we use the array signs. Okay, that's opening and closing of the array equal to, and we have the string hello, how are you doing? Now you can see that the number of spaces here are 1, 2, 3, 4, but we need to figure out how to put that into code. So what we can do is we'll have a counter that's going to help us move along from one character to the other, right? And we'll have another one which will count the number of spaces. So every time counter reaches a space, we will add 1 to number of spaces. Okay, let's initialize this to 0 here, and also counter we'll initialize to 0. Important to note that the string, the first letter in the string, okay, is considered the 0th element in the string. And that's important to remember. Now we'll use the do while loop. So do, our condition will be while str1, and then we use a subscript, right? So this is going to change from 0 to 1 to 2, etc. While str1 at position counter, if you want to read it like that, is not equal to \0. \0 signifies the end of the string in C. Okay, so that's our condition. What do we do within the loop? We will check if str1 at the counter position is not equal to a space, then increase counter by 1 and continue. Else, if it is equal to a space, then what do? Num of spaces plus plus and counter plus plus. Okay. So now if we run this, let's see what happens. Okay, we didn't print out the number of spaces, so we can easily do that where outside this loop, right? So printf the number, or rather the string, has %d spaces. comma, num of spaces. Now let's run this and see what happens. And you have the string as 4 spaces. So this ends our session for today. In the next session, as I said, we'll discuss arrays and strings. Till then, take care, stay safe. Bye.